Now students, we will discuss the property preparation of aldehydes only. Under this, we have at first is the students. I will be writing the preparation first. Those which are the name reactions. Okay, so it is Rosenthal reduction. So here student Rosenthal reduction. Here we will the reactant is acid chloride. It is RCOCl. Now it undergoes reduction when hydrogen gas is treated with RCOCl acid chloride in presence of palladium dissolved in barium sulfate and poisoned by sulfur. Right? Don't forget to write down the sulfur. It is acting as a poison for this catalyst. So we will get RCHO and aldehyde is been formed along with HCl will be also formed here. Now student, a question can come in your mind that why we are using sulfur here and what would happen if we haven't taken sulfur. So if there was no sulfur here, that time this process will continue ahead and we will get the alcohol form. So we want to obtain aldehyde. If we want to obtain the aldehyde, we have to just stop the reaction here only by just limiting the efficiency of the this catalyst, that is palladium dissolved in barium sulfate, by adding sulfur or quinoline, right? So this is one of the name reaction. Now second preparation student is from alkane nitride under the heading Stephen reduction, right? So in Stephen reduction, we'll take alkane nitride. It will be RC triple bond N. This is student alkane nitride. Alkane nitride. It is being treated with mixture of SnCl2 plus HCl. Right? This is 2HCl here. Right? At the first step student, we are going to get RCH double bond NH. This is an aldehyde formed. Right? Now this on hydrolysis H plus and H2O. We show that it is acidic hydrolysis taking place. Now we will get here compound RCHO plus NH2. So we obtain the aldehyde. So in Stephen reduction, the reaction mixture contains the alkane nitride and the reducing agent student is SnCl2 plus HCl. Right? Now student, the reduction of alkane nitride can be also carried by a reducing agent which is known as diverge. Right? Now from alkane nitride, we are going to use divulge, DIVALH. We will obtain the aldehyde. This is not under the Stephen reduction. This is a separate reaction student. Right? So alkane nitride, divulge, and it's give aldehyde. For example, let us write down this is RCN. Now this is divulge. We can also write it up as ALH, and this is Bu whole twice. Now the full form of it, we can write it as di-isobutyl aluminium hydride. Right? The product obtained will be RCHO. So if the alkane nitride has the unsaturation, right? If it has unsaturation, this is alkane nitride, right? it has got the unsaturation. Now if we use diverge here, we will get the aldehyde formed. Right? The unsaturation will remain as it is. So it will not be disturbed. The reduction will be carried at, right? The reduction will be carried at only CN, that is cyanide section only. So it is CH, CH2, and this is CH2. Hope so now the aldehydic group is visible. Right? This was the second preparation. Now students, we will third preparation of aldehyde is from the oxidation of methyl benzene. Right? The next preparation is from the methyl benzene and that to oxidation. Now students, if we use the normal again here, if we use the normal oxidizing agent, that time the methyl benzene or the toluene, it will get converted into benzoic acid. But we have to prepare the benzaldehyde. We are going to prepare. So here we are going to use the oxidizing agent which we are going to use is student is chromyl CrO2 Cl2. This is known as chromyl chloride. So we will use two molecules for one toluene. So we will get a complex form. So CHOCr Cl2OH and this OCr Cl2OH, which on hydrolysis, acid hydrolysis, will give us benzaldehyde. This is benzaldehyde. Along with this, the chromyl chloride will be reobtained. Right? Now, we can also obtain benzaldehyde from methyl benzene by carrying the oxidation with acetic anhydride in presence of chromic oxide. So, under the same heading, oxidation of methyl benzene, we are carrying out the oxidation with acetic anhydride in presence of CrO3. This is OCOCH3, OCOCH3, which is known as benzidine diacetate, which on acidification, or we can say which on acidic hydrolysis, not acidification student, but it is acidic hydrolysis, we will obtain benzaldehyde along with acetic acid, right? So we can get the benzaldehyde obtained from methyl benzene by carrying out its oxidation with acetic anhydride, right? Now next is we can also obtain the benzaldehyde by side chain. Okay student, now here one of the reaction is the name reaction. This is when the methyl benzene is oxidized by chromyl chloride. This is a name reaction student and its name is Itard reaction. Right? So when we are getting the methyl benzene oxidized with chromyl chloride, it is a name reaction and its name is Itard reaction. Right? Now next is side chain halogenation of methyl benzene only. So we are taking methyl benzene, right? You will get it halogenated in presence of chlorine, in presence of sunlight. We will get benzylic chloride, which on again acidic hydrolysis will give us benzaldehyde, and this is the HCl, right? So side chain halogenation of methyl benzene gives the, followed by hydrolysis gives the benzaldehyde form, right? Now we have one more name reaction left here, that is known as Gatterman Koch reaction. Here benzene is being reacted with carbon monoxide and HCl in presence of aluminum chloride to form benzaldehyde, right? So these are the students, the preparation of aldehydes only. We are going to prepare, or we will prepare aldehydes by this method, right? So here it is anhydrous aluminum chloride, and in place of anhydrous aluminum chloride you can also use cuprous chloride also. This is the benzaldehyde which is formed from the Gatterman Koch reaction.